Wanted to do one more example of finding a matrix inverse, and this time we're going to do it with a matrix that has negatives and also has a fraction in it. Now, if we remember correctly, the matrix inverse formula says it's 1 over AD minus BC outside of the matrix D, negative B, negative C, A. Okay, let's have a look at our matrix here. Element A is the negative 1/2, B is negative 2, C is 3, and D is 4. So if we're going to write our inverse matrix, A inverse, we might as well do this second part first because that's the easy part. Alright, we need to swap A and D. So I'm going to end up with a 4 in the top left and a negative 1/2 in the bottom right. And I'm going to change the sign of this. I need a negative B. Currently it already is negative, so I need to make it positive. So this is going to become a positive 2. And the 3 needs to become a negative 3 down there. And finally I need to work out the constant term out the front. We can do that to the side if we like. 1 on AD minus BC. Well, A is negative 1/2. D is 4. So we're going to multiply them together and subtract B times C. B is negative 2. C is 3. Okay, simplifying here. Negative 1/2 times 4. Well, 1/2 times 4 is 2, so negative 1/2 times 4 is negative 2. Negative 2 times 3 is negative 6. But remember, we've got this minus sign in the middle. So this is going to become 1 on minus 2. Minus a minus is plus. And we're going to get here 1 on negative 2 plus 6 is 4. So a quarter is the number we're going to have out the front. So I'll put that in here. Now, as before, we need to multiply this into the brackets. So I'm going to go quarter times 4. Then a quarter times 2. Quarter times negative 3. And a quarter times negative 1/2. Quarter times 4, well, that's just 1. Quarter times 2 is going to be 1/2. Quarter times negative 3 is negative 3/4. Quarter times negative 1/2 is negative 1/8. So here we have our inverse matrix to the original matrix. I'm not going to do this now, but if you were to do A times A inverse, we would have to get the identity element. So I'd like you to have a go at checking that this is the correct inverse matrix.